Okay, so welcome to our Fastlane webinar, Going Serverless with AWS Lambda. My name is Grisha Eckart. I'm your host today, and I'm an authorized instructor by AWS. So I'm running a lot of trainings with them. Most of the times I'm running those trainings through Fastlane, so they're a good partner of mine. A few info about myself. I'm a DevOps enterprise consultant, and you can see here I do have some certifications in AWS just in order to help you out with all those questions. So before we jump into the content, let's just go through some of the Fastlane topics. Fastlane is an experienced, award-winning training provider with a wide range of training methods, such as classroom training or e-learning. Fastlane is particularly specialized in the areas of cloud, cybersecurity, digital transformation, and mobility. As an instructor, and I'm doing a lot of stuff with them, I can definitely recommend Fastlane as a specialist for technology and business training and consulting services. So let's just, visit the web page. So I'll just open up the web page to show you what we are doing today. And today we are doing the webinar on developing on AWS. So this is just a glimpse out of the whole a lot of topics that we have on developing AWS. It's a training, it's a 3-day training, and I've taken module 7 out of this, and Amazon gave us the permission to use those slides for this webinar. And this developing on AWS course, as I said, is a 3-day course. It's got a lot of topics in there, so you're going to be, seeing how to develop with Java, with C# on top of AWS, and it will be going in direction of being a certified developer associate. So there's a certification for this. So if you're interested, I can recommend the training, and I can recommend doing certification. It's well worth your time. And however, there are prerequisites for the training, and as well as for this webinar. You should be, you should have some intermediate level software developing knowledge, and you should also be familiar with some of the AWS services. However, I will try to help you out and be as as going down to the ground as possible. Java, C# or Python, that's going to help a lot, but nonetheless, I think you're going to be able to follow even if you're not. So, okay, let's go back. What's happening in the slides? Okay, so now let's jump into the whole thing. Module 7, it's developing event-driven with AWS Lambda. The course is structured in 3 days, as I said, and there is slides, there is demos, and there is labs. And we will not be able to do the labs, but I have, some demos to show you a bit more so that you feel familiar with what we're doing over here, so that you can follow and think through all the theoretical topics. Right, so what's serverless computing? What is Lambda? Let's see some use cases. Let's see some key concepts and some best practices, and that's how we're going to structure our webinar. What is serverless computing? But the name itself sounds a bit crazy. How can you do serverless computing? It's not possible to do computing in a serverless sense. So, but what does it mean actually? So in a traditional deployment environment where you would have instances, so that would be infrastructure as a service or inside of your own data center, this would be the tasks that you would have as a developer, as a DevOps guy, as an operations guy. So you would have to, provision instances, you would have to put operating systems on top of this, you would have to install the application platform, you would have, of course, build and deploy your apps. That's the actual sense of what we're doing as IT guys. And then, of course, after you've got your app up and running, hopefully it's gonna be popular, so it's gonna scale, and then you will need to scale it, right? So you have to deal with all the load stuff and provisioning more resources, and you will have to deal with high availability and all the stuff. So it's going to be quite a a strenuous job in here and to do all the stuff. And if you're a AWS architect and if you're doing infrastructure as code, there is a lot of stuff to be done, right? Where to place all the infrastructure, how to connect, how to load balance, how to monitor, and all this stuff. And then you have to patch stuff, you have to secure it, you have to monitor stuff. And well, and then at the end, of course, you need to keep your app up and running, so you have to monitor and maintain your apps. That's the traditional environment. Now, in the serverless scenario, that doesn't mean that there's no servers. Actually, servers are on the AWS side. So this is how it looks like on the serverless. So as you can see, a lot of stuff is grayed out. So that's the business of AWS to provide all the necessary resources and all the structures for us. And then we can focus on building and deploying apps. And then we can monitor and maintain our apps. That's going to be our job. And this is the actual place where we are providing value as developers. It's not providing value by all the stuff, like configuring instances and doing all the stuff. That's not how we are productively using our resources. AWS calls this the heavy lifting, and right, we don't want to do the heavy lifting. We just want to do the fun part, which is writing the apps. All right, so now that this is clear, what gains do we have? Well, there's no servers to provision and manage, right? So if there's no servers, at least on our side, we don't have to deal with all those complexities. Those whole services that we will be talking about, they will scale with usage. So if you are, like, let's just take, for example, S3. That's a storage service from AWS where you can put your files on. It just doesn't matter how many files you have. It's going to scale with your usage. And it doesn't even matter how many requests you're putting on top of this. It's all scaled. So that's not going to be a problem for you anymore. It's a problem for AWS, and they know how to deal with that. Very good at this. Resources are being idle. You will not be, in the need to pay for them. So if you have a small application like a small website, a small store, something like that, like a small startup idea, or a job in the back, you will not pay for idle resources. So with the cloud, we're quite flexible. So we could be spinning down instances if we're on the instance side, but we will still need to handle with all of those details. But with serverless, you don't have to do this. If you do not use the service, you're not paying for it. And then the availability and fault tolerance is already built into all of those tools, right? So you are not in the need to do anything about this over here, right? So you can just use it out of the box. And that's really convenient. So what are some common serverless use cases? There is plenty of these. So we into web applications. You do have, websites, even more complex sites like web shops and stuff are all built on top of Lambda and all of the rest of the services already. You can go and see and look for backend. So if you have a mobile app, it could be talking to a backend for database purposes to pull data out of a central database. You could be using IoT, so like things reporting back to your on-prem site or to your cloud site, where you will get all the info about the devices and all the reports, and you then track all this and probably even respond something back to those devices. Data processing can be serverless. You can create yourself EMR servers that are just transient or just serverless, like Athena, for example, where you can do map and reduce. You can do real-time analytics on top of serverless architectures. Batch jobs that run in the background are serverless. So you just design the stuff that you want to run, and then that's basically it. You design the processes like reporting, doing some batch reporting in the background. You can do this. Machine learning inference. Once you've got your machine learning built, you can let it infer all the facts that it gets, and you can use Lambda for this, for example. You can use it for chatbots. That's the typical use case. Or for example, for Alexa, if you want to write an Alexa skills kit, what you can do is you can just provide your utterance where Alexa is going to hear you, and then it's going to tell you which product and then what to do with it. So Alexa, stop playing or something like that. And you can write the Lambda functions in the background that are going to all those with all the actual stuff that needs to be done in the background. And also for IT automation, like policy engines or infrastructure management, like just creating a running a Lambda in the background, like in the evening to do a backup job or something like that, or to remove some resources, all the stuff. So some kind of background stuff can all be done using serverless things. And yeah, and that's how I would also recommend doing this stuff. So serverless, we will be talking specifically about Lambda in this webinar, but let me just tell you that serverless has begun a lot earlier. So for example, Amazon S3, that's something that's been around since the beginning of AWS, and this is actually a serverless service from the perspective of the consumer. You're just storing images or your data or whatever it is on top of S3, and it's growing and it's highly available and it's scalable, and you don't have to do anything about this. And there's other services like that, like for example, the API gateway. You don't have to provide a server as a RESTful interface into your apps. You're just providing the API gateway, or for example, the Amazon DynamoDB, which is a database, a key value database, and value database is, of course, got its shards in the background, but you just don't see them. You just get an endpoint, and you're just talking to that endpoint, and it's going to scale almost limitless. So you can just scale like terabytes, petabytes, and it's going to just scale, and you don't deal with all the servers. Same goes with SQS, SNS. These are all very highly scalable service platform. Step functions to orchestrate your stuff in business workflows, and then doing kinesis with stream processing, where you do, for example, click stream analysis of your web pages, or Athena being a SQL interface on top of non-relational data. You can use all these out of the box without provisioning any servers. And then part of the whole ecosystem is also going to be your developer tools, where you can use the framework, the SDKs, the libraries that Amazon is going to provide you. That's going to make it easier for you to start your journey. All right. A typical architecture over here, a serverless architecture, where you would see how to combine all those services in something meaningful, right? If you got yourself your users down here using a mobile app, or they could be using a web app, and let's just say, for example, that you're storing your web app on top of S3 buckets. So that would be all your static data. You would then distribute those to the CloudFront distribution so that they are near to the customer. At the POPs. The POPs are near at the edge of the networking service, so that you get a good latency down to your customers with the static pages. And then once you have a need to do dynamic interaction, you would talk to the REST APIs of the API gateway, which would provision this also in a highly scalable manner to you, while still providing user authentication, throttling, stuff, and would then be stuff, but some of this would be to talk to Lambda and then invoke functions, which would then serve as a glue in calling all the rest of the stuff, like putting some data into storage, or sending notifications to the user, like that. So that will be the bigger picture of the whole things that we're going to be talking about today. Well, however, we will be focusing mostly on Lambda today, because this is just a short glimpse out of the whole development course. Of course, we will only have the time to do so much. And yeah, let's just continue, because time is valuable and we do have a lot to cover. Let's talk about what is Lambda. If you never heard about it, it's basically you write yourself functional code, basically just one function with some helper functions possibly, and you put it in one line of code, and then you upload it to AWS Lambda. It sits and waits for execution, and it doesn't cost you anything at the beginning. Then we need to invoke Lambda, and we can invoke Lambda in multiple ways, and we will talk about these ways specifically. So we're talking about an event source. This is the creator of the event that's going to happen, and this is going to be calling Lambda. And then Lambda can do a lot of stuff. It can call, external services, other services, do any other stuff, or then when it's finished, if it's synchronous, it would return a response. If it's asynchronous, it wouldn't return a response. It would just log the stuff, and off you would go. Okay, to make this a bit more practical, let's just go into the console and do some. Let's have a look into how this might work. Right. So let's just close this and let's look into the Management Console. So that's the Management Console of AWS. Of course, you should be familiar with this. If you're not, don't worry. Make it as easy as possible for you. So first of all, when you log in, you need to look for the service that you're searching for. So let's go for Lambda. Once you call Lambda, you will see all of your functions that are already existing, and I will create a new function. You can see here, you can author the function from scratch, which we will do just right now, or you can use a blueprint, so something that's already pre-built and you reuse to have it as a starting point, or you can even go and browse the serverless app repository, which is the partner of SAM. SAM is going to be the serverless application model that we will be talking today also in a bit. So I'll show you how to use SAM to make Lambda an easy go, because as you will see, providing all of the necessary resources is going to be quite cumbersome. So it's going to help you a lot with deploying and handling all the infrastructure for Lambda functions. Okay, but right now let's just go and author a function from scratch. So let's give it a name. Because this is the first test. Let's name it test. And then you need to pick a runtime. You get a lot of runtimes to choose from. The latest supported are up at top at the bottom, top at the top. And then you got the older ones, and you can also provide yourself your own ones. Well, we will be just taking the Python one, just for the sake of of example, and then I'll talk about permissions intensively after that. Let's create that function. It's going to take like 5 to 10 seconds to create it. And then we will be presented with an interface where we can write the code. Because we picked Python, or we could also pick Node.js, we will be able to edit the code in line. So we can actually create a code over here while in the console. That's the editor out of the Cloud9 environment. It's called ACE, and you can use it to write your functions directly in the console. That's not going to be what you're going to be doing all the time. Most of the times, if you will be developing Lambda. However, it's neat to have an editor that you can use to quickly do some changes or to see what's in the function. As I said, this only works if you're in Python, and yes, if you're using any other programming language like Java, you will have to upload a zip file, and then you will get your function up and running. As you can see here, you need to name. So the function is the handler is named by the functions file, which is lambda_function, and then lambda handler is the name of the actual function. And so this is how Lambda finds its way into the file, because you could have potentially multiple functions and only one is the actual handler. The handler gets an event object and a context object. We will be talking about this in a second, and this function doesn't do anything right now except that it returns a dictionary here with a status code of 200 and some nice words. Hello from Lambda. Okay, let's use that function to execute it once and then see what happens, because now it's just sitting there. It just doesn't do anything. Let's test it. So if you do a test, first you have to configure the test event. Test event is the info that gets passed to the Lambda function. So let's just name it, and I will not change it right now because there's no sense in doing this currently. And after it's done, it's named, and you can pick up to 10 test events, which is nice. So you can test your functions correctly, and then you just click all the results. So you can see here the execution has succeeded, and that's the response from Lambda. What the log output is doing, and how much how long it took, and how much it got built for us. So it's going to be billing for 100 milliseconds for this function at 128 megabytes. So see later on, that's one of the major things that you need to take care of. Okay, let's go further down. Let's see into the monitoring field. We'll see here no data is currently available because I've just executed that function, and it's going to take a while until it's visible. Also, you will see down here, you will see the executions of the Lambda functions, which are going to be put in log streams. So if you open this one up, you can see here that's the log stream, that's the data. And if you click on this, you're going to go back to the CloudWatch console, and you will see exactly what happened at which point in time. So that's one of my older executions. No, it's exactly from this one because it's UTC. It's 4:50 in German time, and that's exactly the data. So it got logged correctly. So let's go back to our log console, and let's see if there is a call already present. And you can see here, wow, we got one execution of the one invocation of our Lambda function. It's going to be monitoring all the stuff later on when we do more multiple executions. Now let's go back to the configuration. There is something to be told about the upper part, which is called the designer. We will be talking about this later on. And then below here, you can set environment variables. When you need to pass in some information for a specific function, you can use environment variables. You should also tag your functions to recognize them later. And then over here, what you can do is you can increase the amount of memory that your function has got. So right now we're 1 gig. And this is not only the memory of the function, but also the CPU and also the network. If you are increasing this number here, you're not only increasing the size that you can use, size-wise in memory, if your load is memory bound, but it is also going to be increasing CPU. Once you go above 1.8 gig, you will get a second CPU. So that's nice. So if you need to do some threads and stuff like that, which is kind of questionable if you should do it inside Lambda, but you could, and then you will get a second ASIC. Default, there is a configuration of 3 seconds as a timeout for the Lambda function. So after 3 seconds, if it's not done, it's gonna be ending. It's gonna be it's gonna be a hard die of the function. It's gonna be killed. So that's also nice that you can limit the functions, and the maximum timeout is going to be 15 minutes. So these functions are not for long-running processes. These functions are to just do the job quickly, and a maximum of 15 minutes. All right, so let's leave the rest for later, and let's go back into our slides, and then let's continue from here. Okay. That was a short glimpse into how Lambda works, so that you can have a better view of the actual concrete working of in the management console. Right, so now let's talk about how to Lambda. Well, you can bring your own code. So if you're using Node.js, Java, Python, whatever you're using, you can bring your zip files and you can just upload. You can use custom runtimes if you want to. You can bring your own libraries with you. We will see that we will have flexible use in terms of synchronous, asynchronous, or streaming services, and I'll show you this in a second. And then we got a simple resource model, as we've shown, 128 meg to 3 gig, and CPU and network allocated proportionately. Authorization, we're going to talk about in detail, because that's important to know how Lambda can execute stuff inside of your AWS environment securely, and we will be talking about this in depth. You can also author functions inside the VisiVig editor or upload them with zip. You can use the Cloud9 IDE. That's a distributed Cloud9. It's a development environment by AWS that you can use to collaboratively work on the same code base. Kind of nice. You can try it out. Just start yourself a Cloud9 service if you're interested. It's all web-based, so you will not have anything on your laptop except of a browser. So it's kind of nice. Or you can use your PyCharm, stuff like that, where you will have third-party plugins like AWS Toolkit installed, so that you can access to your Lambda functions. Programming model. Inside a Lambda function, it's you basically just use your programming language. If you are calling any AWS stuff that's kind of cool that the SDK is already built in. So if you're, for example, using Python or Node.js, you don't have to include any libraries. Boto 3 and the Node.js are already included in the base container. Inside Lambda, you can create yourself threads or processes. You can also have access to the /temp directory if you need to write some files. Be aware that you do not know where the execution is going to happen if you're going to be on the same device the next time it's going to be running, because AWS is going to be scheduling those functions onto different machines. So they might be, be scheduled on the same machine, or they could be scheduled on a different machine. So if you're relying on two function calls being on the same machine, you will lose. You have to be aware of this. So AWS is going to be shifting around the stuff as they see fit. They're going to reuse the stuff if you have low usage, but they will be spinning up new instances, the VMs on top of this. Basically, a Lambda execution environment is just a micro VM, a very small virtual machine that will be started on some server, and Amazon is doing all the necessary stuff in the background. Sockets, if you want to talk outside of the Lambda, there's no way to talk into the Lambda. There's, of course, the ability to do monitoring and logging, and I've showed you the monitoring for the requests and for the logs. There's also the ability to do some distributed tracing. If you activate this, you can see which function is calling which function, how, what the latencies are, if everything is going to go green or red or whatever it is. And functions are stateless, so you will not be able to keep state inside a function. You can try to do lazy loading, for example. If you've got a connection to your database, you can see if the variable is not null, you open up the connection to the database. But if it is null, you open the connection. If it's not null, you just reuse that connection. So this is a sum of the state that you can actually keep and to use for speeding up stuff like a little bit like caching. But other than that, there is no persistency on Lambda. So use other database storage for this, and there's going to be no affinity to your underlying infrastructure, which you have to keep this in mind. Okay, so now we got our Lambda function. Now it's sitting there, but it's not going to be executed, except right now we're doing the test, right? So what well, we can do with, for example, for Amazon S3, you can have Amazon S3 firing up an event once you are publishing an object inside S3. And let's just say, for example, that we want to do just that. So let's just go back into our console, and let's just create a new function, and that's going to be using an S3 bucket out of the box. So now we're not going to author script, we will be using a blueprint. So let's go and say S3. Let's see what's in here. So you search for the blueprint, and you can see here there is an S3 get object blueprint that we can reuse. So let's just take this one and reuse it. So let's name it get object. Maybe the name. And now we have to give it an execution role, because this get object is going to be reading out of an S3 bucket. We have to give it permission to read out of the S3 bucket. So this is what is being done down here. So this is our policy template. We will be reading from S3 with read-only permissions, and we have to create a new role. That's what I'm choosing here. We could also reuse one if we had one, but so let's just give it a name here. So this is going to be S3 read. All right, let's just name this way, and then we're gonna be placing inside this blueprint. It's already pre-configured. You can create triggers. We'll create a trigger on one of my buckets that are already existing. Let's just take it. And then let's create events. But when do we create events? When this is what we can choose over here. We will do for all object create events. Okay. To be using some prefixes or suffixes, but we were not going to be using this. And then we will enable the trigger so that it's going to be, firing as soon as we're pushing something up the S3 bucket. Now let's look into the function. How does it look like? Well, you got your handler, of course. The boot client, this is the client for accessing the AWS functions from Python. By the way, is the name of a dolphin that is swimming in the Amazon River. So using Amazon as an analogy over here. So this is what they named it, Photo. And then you are creating yourself an S3 client, and then you are going to be using this S3 client later on to get object using its bucket and its name, and we will be getting that object back, and then we will see and take its content type, and we're going to print a content type into our logs. This is basically all that the function is going to be doing. But to get the name of the bucket and the key, the function has to parse the event. So the event is going to be passed to your Lambda handler, and inside the event there is going to be all the info that you need. So in this case, this is going to be a S3 event. So in this S3 event, we were going to be looking for the records field, and then the first of this records, and then we're going to be using for the S3 bucket name. It's going to be our bucket, and then the same we're going to do for the object key, which is the name of the file. So now that we've got the name, the file, and the bucket, we can get its info, and then we can print it out. So this is what the function is actually doing. So it's just triggering when you're pushing in the file, it's triggering the function, and then it's going to be executing exactly this. Create a function. So apparently I had a webinar before where I named my role exactly the same. Let's create a new role anyway. So we could be reusing the old one. This was the third webinar about Lambda today, and don't forget that we do have a VPC webinar following on the next Friday, which I would really recommend because you should really understand VPCs when you are dealing with AWS. Now that we've got our function up and running over here, it's sitting here and it's waiting for an event. And the event is going to come, if you open up the designer, you will see here, this is the left-hand side. This is where the triggers are coming from. It's coming from an S3 bucket. Okay, and on the right-hand side, by the way, this is what the permissions you will have. So we do have permissions for log, permissions for reading from S3. Okay, so let's just do this. Let's just pump a file into our S3 bucket, and then let's see what's happening. So in the S3 console, I'm gonna upload a file. So let's add a file. Let's just take the Kubernetes logo. Let's just upload it. All right, so now in the background, the Lambda should have fired. So let's see if we see something in here. And there is something happening. So let's see if we do get the current one. No, not yet. But we can go into the CloudWatch logs. What happened there? Here we do have a event. It's fired up just a few seconds ago. So it loaded the function, and the function is reporting content type is image SVG plus XML. So this is exactly what I have uploaded. And so this is how I could show you what the connection between S3 trigger and then the Lambda function invocation is. So this was an asynchronous event. Right. So going back to our presentation, so this was a way of how to integrate S3 into the whole Lambda trigger situation. Things would be like doing DynamoDB, which is streaming all the changes to a DynamoDB stream where you can process them using Lambda. You can do the same using SNS and Kinesis, so you can just listen for over here for notifications, and over here you can watch for click streams, for example. Emails can be used as a entry point into Lambda. AWS config. When something changes inside of your AWS configuration, that's a bit more security type of things. You can Lambdas in the background using a cron job, for example. They can be sitting just behind the load balancer directly. You can be listening to queues, and we will have a look into how the API gateway is firing off the Lambda. And then also you can be using a lot of other stuff, like listening for Alexa utterances and HTTPS responses, requests from the gateway. All right, this is a multitude of ways of triggering Lambda inside AWS, and this is what makes the power of AWS. So having serverless functions, at home or in your Kubernetes cluster might be nice, but at Amazon's all of those, the ecosystem of all of those events firing from everywhere, where you can really use them productively. So it's even stronger. Okay, so let's look into some key concepts. We already talked about the handler function, right? This is the function that's going to be executed, and then you need to get passed in a event object. The event object is structured specifically to the event type. So if you are calling this from an HTTP request, you're going to get HTTP data. If this is going to be called from S3, you're going to get S3 data. And data is passed in JSON or as a dictionary, and in Java it's POJOS, and in C# it's POCOS and whatnot. And you also get passed the context object, which we didn't talk about before. So this is providing you the info about the execution and the the circumstances of the execution. So you will get identity of the function. So you're going to get the function name, for example. You're going to get the amount of time it has to live, so you can see and check if your function is about to get killed because the time is running out. You can get its unique request ID and other stuff about the client. So the client could be, for example, a mobile client, so you can get an info if this is an iOS application that is calling it, or for the log stream is being used for logging the data. The function handler, as we've already seen it, has to be somehow and specify the function handler in the Lambda configuration. The event and the context. You can use the event to parse out stuff like the first name inside of the object. This is how you are returning stuff if you are in a request response example. Okay. So let's go ahead. So the same is going on for Java. Java has got it's a bit more typed. So this is how it looks like in Java. And you can see syntactic sugar, C#, and we will not be using this examples in more depth, but just to explain this, the whole developing on AWS course is structured so that it fits a lot of different developer types. So if you're coming from Python, if you're more DevOpsy, a bit more system operations guy, you would go for DevOps, or for example, if you are into machine learning. Then if you are from a Windows more style of environment, you get to use C#, and if you're from Java, you get to Java. So all the lab structured in the three different languages, which is kind of nice if you're going into the training. All right, so how does Lambda work? So this Lambda function is a combination of the code plus its dependencies plus its configuration. That will be all the configuration that is hanging on the Lambda function. Can be invoked using event sources, pull, push, and the request response. And we will be looking into these in more depth just in a second. And of course, it can be authored in those different languages. You can deploy using your favorite tools. You can do it in the console, do it from the CLI, you can do it from the SDK. If your SDK is a lot of tools that is being supported. Specifically in the lab, we are using Visual Studio, Eclipse, and PyCharm. But you can also be using the Cloud9 environment if you want to. Right. So when you are using your specific language, you need to provide the resources in the correct way. So using interpreted languages, you do it this way. If you're using Java, you're using it this way. And if you're using C#, you're doing it this way, right? So like using your favorite package manager, npm, you get Visual Studio. Of course, you have to play your artifacts in the correct directories before uploading them. You write a function, you create a Lambda handler in your code, you create the Lambda function, and then you need to assign it a role to assume on. So each and every service and everything inside AWS has to have permissions to do anything. And the way to assign permissions to Lambda functions is to use so-called roles. You can assign permissions to roles, and then you can tell Lambda to use your function to assume a specific role. You can upload the code, you can invoke the Lambda function, and you can then monitor it into the CloudWatch. And we have already seen most of this, but we will focus on IAM right now. Before we do that, let's just talk about execution models. So we will have, the asynchronous model, which we've just seen. So S3 is firing off an event. And S3 is informing us about, some file has been uploaded to S3. Now, S3 is going to fire up a Lambda function, or it's going to give it a trigger to fire a Lambda function. It's not going to do this directly. And it's a fire and forget info because, it's just application. So S3 doesn't care what Lambda is doing with that function. If Lambda wants to do something to the file, it has to write it back somehow. That's going to be the job of Lambda. So S3 is not going to be waiting for any response. So this is why it's called asynchronous. On the other hand, if you've got a mobile client here that is calling up a REST interface, then executing a Lambda function to provide a result, the result is going to be passed back as a response and then passed back to the actual device in a synchronous manner. So the device is going to wait for this to happen. And only then the request response is going to be finished. So that's going to be a synchronous call. And then there's also stream-based calls we won't be doing and won't be seeing here in this example over here, because this is more to fetching stuff from DynamoDB streams or fetching messages out of topics from Kinesis, for example, or even SQS. So that's more stream-based. We're not going to talk about this here. But to show you the synchronous example, I will like to spin up a example using an API gateway and a simple REST interface using a Lambda function. And to do this, I will not use this inside the console, which this would be a lot of clicking. So you would have to create yourself an API and create the corresponding resource and then the corresponding message. And then you would need to assign a Lambda function to this. And to do this more automatically, I'll show you how to do this in a modern way. So if you're interested, just go in and say SAM and then AWS. And you should be directed to the serverless application model, which is this little squirrel over here. So easy to remember, is doing the Lambda stuff. So the SAM, the serverless application model, is the best way to build simple and clean syntax. And for this to be working, you would need to install yourself a SAM CLI. You can do this for all those different environments. And what does it help for? Well, it's a super cool single deployment configuration tool. So you can use SAM to organize all of your components into a single directory, and you can version all the stuff. You can version it as an entity. You can spin up API gateways, databases, all the stuff out of just a single file configuration. As on its backend, and we have been talking about CloudFormation, the first webinar that we had a week ago. So if you don't find this, if you haven't been there, you should be looking at the video that's going to be provided by Fastlane. As soon as it's up there, you're going to see it on the webpage. Not only does it help you with creating all of those applications easily, but you can also do some local testing and debugging, and I'll show you how this works. It also has got some best practices built in, and it's integrated nicely into a lot of tools. And it's built on top of CloudFormation, as I said. It's an extension of CloudFormation, and I'll show you. All right, so let's just go to my terminal, and let's just see where we currently are. So, okay, here I've got my SAM client already installed. SAM. You have to install it, of course, and then you need to know what do you want to do, right? So let's say SAM install init. We don't know what the actual commands are, so we are executing a help. And with -r, you can specify the runtime. So let's do SAM init. Specify the Python 3.7. I've created a project inside the directory. It's a sam-app. Let's open this up. In my editor, the only product I'm using over here to edit stuff. Okay, so that's the basic template over here from this Hello World example. It's a Hello World example, and if you have time, I'll show you another one later on. It's a bit more complex, so but let's just start with this one. So this is a template file from CloudFormation, and if you see this transform tag over here, this means that this is a SAM file. So what it will help you with, it makes it much more terse. So this is like 40 lines of code. This would be, you know, at least 5 to 10 times more verbose. So there's a lot of stuff that you would need to write, and it's much simpler doing it over here. So for example, this is the resource that we will be creating, which is a function. So you see here, it's an AWS Serverless function. It's been named AWS App Lambda Handler. That's the function name inside of the whole thing. And Hello World is the folder that it's in, and the runtime is 3.7. And it's going to be triggered by an event, and the event is going to be called Hello World, and it's been from the type API. So what we'll do is create for us an API gateway with the following source and the following method. So that's going to be pre-configured for us, so we don't have to do all the, you know, all the heavy lifting. Okay, so now let's deploy this into our environment. Up a new terminal. Okay, because we are unexperienced, we need to read some documentation. So let's open up MD file over here. And you can see here, you have to create yourself a bucket. So this is the command for creating a bucket. And then after you've got your bucket with a specified name, you need to call this specific command, and it's called SAM package. It's going to package all the files and modify the template file. So I'll do this. To specify my MFA because this is very secure. And don't use MFA tokens, guys. You should really activate those on your environments, because otherwise people could be stealing your password, or you could, you know, just be checking it out somewhere, and then bad things could be happening. You don't want to do this. So use MFA tokens. Once we got this, we need to deploy it. So this is basically just executing that CloudFormation script. It's going to be the same. This is basically just the same as executing this AWS CloudFormation deploy command. Let's do it. And then once it's done, we will be taking the output from the CloudFormation stack and see what's being created. Before this is just going to take like 10 seconds or so. Let's just go in there and see what's actually happening in here. Let's go into Lambda first. You'll see here that now under applications, under AWS Lambda, under applications, there will be an application coming up as soon as it's there. Let's see if we already got one. Yes, there it is. So you click on the SAM app. It's still in progress. The whole thing, you know, the complete environment included into the AWS Lambda environment. What it's going to do is create a Lambda function, which is called hello world, and then it's going to create a serverless REST API. And once this is done, we will get an endpoint from that API, which we already got over here, and go back into our Studio code. This is done. Let's just paste in the other code. Here, this is now our API endpoint. Here, and let's just execute this. And you'll see, okay, hello world, right? This is what got executed after we've created the function. So this is REST endpoint calling up that Lambda function, which in turn is then responding with this message. Now, it's need to do all the stuff directly using CloudFormation and just using some so few lines of code to get this stuff up and running. But it even helps you more because it's got some other features, like for example, local execution. So if you want to execute this locally, what you would do is, you just start your API on the local machine, which we'll do right now. And so you can do some local debugging, which is nicer than publishing everything before you can continue. All right. So now let's open up a new console here, and let's just use that output here to do a curl. And the resource was named hello. Now, this locally, I've got the security set up correctly, and this is what's going to happen. So I'm going to get asked for your MFA token again. Being cached, so you will not have to do this all the time. So now the function invocation was done locally using Docker containers. So the whole Lambda environment, or at least a good copy of it, is being replicated locally using a Lambda container. You can see the execution over here, how long it took, and we got the response. If we go back to Bash shell, you can see here world return. Now going back to my Python, the whole process of serving that locally in SAM is running, and I can do a hot swap of my code, right? So if I'm writing some changes in here, I want to say hello. This webinar. Right. I can save this. Then I'll have to write in my just redo that curl. I'll have to do the MFA again. MFA was not good enough. Oh, that's a problem. Copy pasting here on my side. And you can see we got hot swap, and the result has been hello serverless webinar. Now we tested this correctly, and there is also included, by the way, are including unit tests in here. So you should be doing TDD, and there is a TDD framework in here included. So you could use this. But once you tested all the stuff, once you checked that it's all running, you're now ready to upload the code to Amazon. Let's go and do the batch again. Do the deploy again. Set is going to be created on CloudFormation, and the change set is going to be executing. And because this is just the change of a Lambda function, this is quite quick. So we are expecting this to be done quite quickly, and we are already done. So if you do a reload over here, there you have it. You get a full development cycle in a very short amount of time. So this is how you can use the SAM framework to create yourself a complete application. But yeah, I didn't show you the API gateway. If you're interested, we can click on that gateway down here. So you can see, okay, this is now the gateway from the SAM app, one that we created, and you can see here the resource, and then you can see here the method we are actually using to execute the request. And you can see here, if you are familiar with API gateway, you get your integration request. And over here, we are using Lambda proxy integration, which means that we are getting past the complete, call from HTTP is being parsed, and then Lambda is responding to that. So this is how a synchronous call is made using Lambda and integrated into the framework. So that was the synchronous API gateway call. And we saw the asynchronous one, and we do have the stream-based one, which we will not look into. Okay, so push event. What has happened? We have an event using Amazon S3, and then this is has been processing the files. In pull events, which we haven't looked, the AWS Lambda is going to pull some events out of the SQL or DynamoDB streams. A specific way of working that we were not going to be looking. Okay, I see here there's some questions. Let's just see if these are something that I can do quickly. So somebody is asking, is this a CLI tool to deploy Lambda? Yes, exactly. So SAM is a CLI tool, but not only to deploy Lambda, but also to do all the the database if you have got one, but also to do S3 buckets. So it's more an integrated way of doing serverless functions. And you don't need to enter MFA all the time. That was just my specific scenario over here. I'm super secure, so I have to do this because I'm showing this on the screen. Somebody would be, doing crazy stuff with this while I'm recording this. So this is why I'm using a secure way of working, but that's not the usual case. And the next question is how to add security to the Lambda function, which we will be talking about just right now. So that was the pull model. And then we also showed you how to use the request response model, which we used the API gateway for, and we returned an HTTP code back for the REST API call. Now, how do we add security to the Lambda functions? Well, it's not only the Lambda function itself that we need to provide, we also need to provide its execution role. And the execution role is going to be the main thing that is going to tell you what the Lambda function actually can be doing. So the IAM policy permissions, and we will not be talking about IAM, guys, so sorry about that, but that's just well beyond the topic here. You will need to have at least 3 to 5 days of all, the background and all the architectural stuff before we can talk about this in more concrete details, but I'll show you an example. And these are policies, are permissions that you can add on top of a principal. Such a principal could be an execution role. And then you need to say that the Lambda service is allowed to assume that role, and only then you will have an allowed action. So that's a very important thing. So if you do not have that execution role, the action is going to be forbidden. So execution permissions example, this is what we're doing over here. So we do have an access policy. The access policy is telling the Lambda function what it can actually do inside AWS. So this function here can do some log group creation, some log stream creation, and some put log events. So this is to write events into the event log, which is important. So this is the minimum what a function needs to have. So that's the minimum access policy that it needs to have. And then the trust policy is that you are actually allowing AWS Lambda to assume that role. So this is what we're doing over here. So that's the second part of the execution permission. And only if you provide both of these, you will be, giving the rights to Lambda to actually do that stuff. By itself, it's not going to be allowed to do anything. This is the minimum that it needs to have. And if you need something in addition to this, you will need to add those actions on top of that. So, for example, if we are looking back into S3, our example that we did when we wrote our getObject function, this one here, it got the permission to read from S3. So how does this look like? So if you click on that key here, you'll get the function policy and the execution policy. The execution policy is the one we've been talking about now. The execution policy, except from doing the create log group, create log stream, and put log events, which is the minimum, it also has got the S3 get object. So only because I'm allowing this, the function has actually got the right to do. Otherwise, it wouldn't be able to read from that object. The second thing that it needs to have is a function policy, which is also called the invocation policy. So the invocation policy is the policy that will allow other services to call Lambda. So for example, S3 is calling Lambda, so it's using the action Lambda invoke function, and only because it's got this specific permission, only this is the reason why S3 can actually call that function. So, it's going to be able to call the function. Is the function going to be able to be doing? And this is what you can see here from the top level. You can see here that you got S3 included as a trigger, and this is that you need to write. You also need to write that permission. And on the right-hand side, you see the role permissions that the function has got. You do get this on a single view. So that's permission-wise. Let's go back to the presentation. All right. So now we got permissions for our example here. So if you are doing which we have, like for example S3, firing up a resource, you would have to have this kind of resource policy. That was the function invocation permission. If S3 doesn't have that permission, it's going to not be able to call the function. And the execution role is going to give Lambda the permission to access other services. Pool-based scenario, this is a bit more complex because we are polling actually, and then there's so event source mappings, and we will not be talking about this. Okay, so we talked about the push model, we talked about the pull model, and that you need to have all of those permissions, because otherwise you will not be able to use the functions. The push example, as we said, you need to have the permission to invoke the function, and S3 has got that permission, and the API gateway would in this case also get the permission to execution. That's the invocation function permission. Okay, so now let's pass on and let's go on to the next one, which is the function execution. So let's talk about the functions a bit more. As I said, it's a virtual machine that's being fired up by AWS. And it's going to be executing the function. So maximum time is 900 seconds, and 3 is the default, but you can go up to 900, but that's a hard limit. So you cannot go past these 15 minutes. And duration is calculated the time the code begins executing and returns, but it's rounded up to 100 milliseconds. Also do function scheduling. So if you want to, you can fire up your function using a cron job. So you specify a cron expression. So this is going to be a typical Unix way of specifying a time frame. So every 15 minutes or so, or every evening, 8 o'clock or whatever, you can fire up an event. And then from this event, you can trigger a Lambda function to do a backup, to do some cleanup, or do whatever you want in terms of starting a function in the background. So this is how you can schedule a function. Let's talk about restrictions a bit. So the Lambda functions cannot do everything. So there's, for example, no inbound network connections possible. They're blocked by AWS Lambda, but you can do outbound traffic. You also cannot do ptrace, so debugging system calls, it's not possible. And also you cannot use TCP port 25 outbound, because spamming is a real problem, and as an anti-spam measure, AWS has restricted this. So some restrictions. Okay, so now let's talk about deployment, right? We're in the DevOps world. A lot of stuff is happening in the DevOps area, and we've been, talking a lot in the industry about zero downtime deployments, about A/B testing, about canary deployments, and all the stuff. Come with a new way of deploying stuff like Lambda functions. You should be prepared, of course, to do all of that DevOps stuff. So let's talk about versions. Versions are a way to enable a lot of stuff inside AWS Lambda. Versions are immutable copies of code plus configuration. So you get your copy of your code plus your configuration, and this is going to be versioned, and it's going to be fixed at version. Right? You can then put aliases as mutable pointers to version. So for example, if you have aliases called prod, you could be then pointing this to a specific version. So prod is pointing to version 5, and dev is pointing to version 10, for example, and we'll see this in a moment. Development is always against the latest version. So when you're developing stuff, you are doing this to the latest $latest. That's the version's name. And you can create versions whenever you want inside of the interface. Each version gets its own ARN that you can identify specifically and precisely. Go to a real world example. You are developing an application, and it's a super cool hello world, and you are adding the new features. So this is going to be the $latest. So that's going to be the newest version. So as a developer, you're creating this stuff. You can be a dev alias to point to exactly to $latest. So you're going to be working with a hot shit. You want to publish that stuff, but when you're publishing stuff, you don't want to corrupt your production. You don't want to corrupt your productive users, your staging users, all of the rest of the environment. So this is why you probably don't want latest to be the version for most people to be using. So you can go to, for example, if you're using a production user would have a production alias set up so that it goes to the first stable version, which in this case would be version 1, for example. Prod will have version 1 running, and they will always be using version 1. You are producing your new version. There is absolutely no conflict between the two, because these are separated completely, because they're using different versions, and these are immutable. So prod is going to be seeing the production version. You could also be creating a new user, like a beta user or a A/B testing user, which would be calling the function version 2, which perhaps is a newer version. Perhaps it's some updates that you made, and you want to have a specific group testing those new things. Or you might have a specific user who's saying, I want to have a new feature. My button should be red, not blue. You give them this specific version over here, and they will be able to use that version. And this is not going to interfere among each other, and this is how you solve this. And this way you can do canary deployment, for example, to specific users, and doing all that new DevOps stuff. Let's talk about Lambda layers for a minute. Lambda layers is a way to factor out code that is common amongst a multiple functions. So if you've got multiple functions created that all have got the same access to the same database, all the same code in there, you could create yourself a Lambda layer, and then you could include it into your function, still keeping your function very thin, and putting all the duplicated code into a Lambda layer, and then all of the functions that would be using this layer, that same code. You can have up to 5 layers. They're a bit limited in terms of size, but that's okay and good because this is exactly what we want to have. It's not going to be too big. Copying it around, it's not going to be taking too much time. That's Lambda layer. Let's talk about pricing. Okay, so pricing is cool with Lambda because you get 1 million calls for free per month. So even if you go well above this, like 30 million calls per month, which would be 1 million per day, when you allocate yourself 128 megs of memory, which is the minimum, and then run very quickly, what AWS would charge you is $11 plus something, and you know, running in some other region might be a bit more expensive, but not by a lot, but not by a high margin. And you're only paying for what you're actually using, so using based on top of your functions. So if you've got a small website, or not using it that much, you're going to pay zero cost for Lambda. Length of time is also important. So if your functions are running for a longer period of time, then of course more costly. And memory, of course, also important because this is how much memory is going to be allocated for the function. Some guy in the previous webinar has asked me how to decide on using between EC2 and using Lambda, and you have to do your calculation, right? So if you've got a lot of calls constantly being called by a streaming service, it might be that an EC2 instance might have a lower overall cost, because if you've been doing like millions of calls continuously, this is probably a better service for this. But for anything that is highly, where the scale is going up and down all the time, and you have zero usage all the time, Lambda might be a very good case. All right. So this is what we have in terms of the costs. So before we are ending up our webinar, let's just go and look into your questions, guys. Do you have any questions so far? Into the Q&A, your Q&A box, or you can write into the chat. I'm going to give you a second example using SAM. Just come up with your questions in the meantime. Some questions. How can we do Lambda function sync communication? So if you've got multiple Lambda functions and you can be calling them directly if you want to. So the question is, how can we do synchronous communication between Lambda functions? You could be calling directly from the other function. So this could be a way of working. So this would be a very highly coupled way of working. The other way would be to create messages. Even if you be doing messages that would be be considered synchronous, you could have a queue going out and a queue coming in. So you could be doing this. You could also be using internal API gateways in front of internal functions. So function is calling a REST API interface, and then this REST API interface is calling another function. So this way you would decouple stuff, and you would have a API gateway in front of every Lambda, which would then make your APIs a bit better, which I think is going to be a better way of working. So putting an API in front of every interface, it might be nice. Yeah, so you a lot of options, and to be honest, this is going to take a long time to get all the options on the table to see what's available by AWS, because the tool set is so big and there's so much stuff you could be using. So I can really recommend any of these trainings, guys. It's not just for ad purposes, but it's also really important to have a good and well-developed training to get to know all of those resources. We get another question. So let's see here. Another question: what's the difference between using SAM and EC2 CLI to create a bucket? So if you're creating a bucket, you can do this inside of the AWS console. You can do this from the AWS CLI. So there is basically no difference between those two. You go into CloudFormation, which SAM basically is. So SAM basically is something built on top of CloudFormation. We are talking about infrastructure as code. So infrastructure as code is combining a lot of the tools that are available inside AWS, and it's combining them into one file. So you will control a lot of stuff. So a lot more can be done inside a CloudFormation template, because you can be interconnecting all the individual parts. And this is why it's so important to have them in SAM. In the SAM file, you've got everything included together into one file. So you don't have the spread out stuff, and you don't have to do all this, in distinct pieces. And also when you're running such a CloudFormation template, it's either done completely and it's all good, or it's going to be rolling back and it's not going to be, staying there in some undefinite state. So this is why it's so important to have to have something like CloudFormation sitting on top of this. The result is going to be the same. It's just a way how to manage the stuff. It's going to be a lot easier to manage the stuff in a controlled manner. But in order to understand where it fits you the best, you should be experimenting with this and see, okay, what can CloudFormation bring me? What can SAM bring me? What Lambda cannot? And SAM is making it so much easier to write those templates, and so much easier to write functions in a concise and precise way. If you can use Lambda to send HTTP requests to the internet, yes, you can. So you can use the Lambda inside Lambda. You can do some sockets, TCP/IP traffic, so you can originate from the inside to the outside world. Yes, that's possible. If you got more questions, just propose them. In the meantime, I'll show you a example using SAM. If you want to see this example, you go SAM OCR AWS, for example, in Google. We'll get the an example over here that you can use in the application model in the documentation on how to process S3 events. And you follow the instructions in here, and you'll be able to do all the stuff that I'm showing right now. Let's, for example's purposes, let's just go and go into my console. I already got these files down here. Let's open it up in my editor. Now, that's also a folder. So this is the template. It's more complicated, but not by a large margin. So let's see what we need to do, and let's just deploy all the stuff. So it's the same thing. Create the bucket, and then use that bucket to package all the files. This is what I'm going to do right now. My usual suspect over here to upload all the resources, and then I will do a SAM deploy. And somebody has used the incorrect way to name stack name. Scores are not accepted. Okay. So the whole example is being spun up on AWS, and while it's doing this, I will show you what's happening in the background. So there's a resource at the function that is searching through a file text in there. So it does so by accessing the S3 bucket. It does call Amazon recognition to detect text and labels, and it uses the DynamoDB table to put items and all the other stuff. And as an event, it uses the S3 bucket as we saw before, and it creates a table. Now, this is how simple it is to create a table inside SAM. If you've seen this, doing this manually or doing this using CloudFormation in a typical way, this is much more terse over here. So it's a really concise way of writing stuff. Now let's go into the actual Lambda function. What does it do? Well, besides create some clients, the actual handler over here, it gets the bucket, it gets the key name, that's the file name, and then it does detect the text. So it calls the file text on top of the file. So we will need to provide an image, and it's going to detect the text over there. And then after, the next thing is going to detect some labels. It's going to find and look for any images that it finds on the image, and it's going to name them. And then once it's done, it's going to put all the items into a DynamoDB table. A very quick way to demonstrate a top-level service that is recognizing this inside of Lambda. Okay, so now let's go into our management console. Go here, oops, reload. Let's go to S3. A bucket has been created, and its name is OCR source image bucket. So this is where we need to put our image. So let's drop in an image, and I've created a screenshot of a webinar page, and I'm going to be, that's how it looks like, right? So there's a computer over here, and there's text, and yeah, let's see how it gets recognized. File is uploaded, it's a success. So here's the file. Now let's go and see what happened, right? If you remember, it's going to be recognizing the stuff, and then the result is going to be put into DynamoDB. So let's go into DynamoDB. Tables. Let's take that results over here. Go into items, and there's one item down here that has just been uploaded just a few seconds ago. Yeah, let's just click on this, and you will see this is the labels that it recognized. So it sees text, a page, a document, a file, a computer. That was the laptop that was shown over there, a PC, a laptop, right? So this is what it recognized. It also recognized text. So you can see all the text fields over here. So it's AWS Fastlane webinars, the date with CloudFormation, with Don't Fear the Serverless VPC. And by the way, this is something that I need to remind you is that I do have another VPC webinar running the next week. So I hope you will be there, because as I said, it's very important to understand the technical details of the networking infrastructure. And these are all the words that have been recognized on top of that paper. This is what concludes the demo over here. And this is what also concludes our presentation for today. Thank you that you've been here. Hopefully it was well worth your time. I would like to point out that Fastlane is doing the developing and architecting and all the rest of the trainings. Just visit the webpage, and don't forget to register for the next webinar. If you get any questions, I will be here for another 5 minutes. So just hit it, guys. Otherwise, have a very pleasant weekend. It's Friday evening in Germany, and I hope see you next time. So there's a question around the certification. Yes, there is a certification that you can do. There's a lot of certifications for AWS, and I can really recommend these, because these are really, these are heavy weight tests. At least some of them are really heavyweight, and I can really recommend this to you guys. So if you see over here, today we are the AWS Developer Associate certification preparation. So if you click on this, you will see how the certification looks like, and it's a something like 3 hours of tests, and I can really recommend this. So all of them are very cool, because I mean, you get a lot of a big list of like Solutions Architect Associate, Developer Associate, CSAP Administrator. These are the easier ones. However, that's not mean that it's going to be easy, but they're quite cool. And then there are the professional ones, which are even more complex, and these are the hard ones in here. And then there's also some specialty stuff. So if you're into, machine learning or big data, you can do any of these. So yes, there is a lot of certifications, and I can really recommend these, right? It's going to be a tough job, but go for it, guys.